If you've been planning a vacation, take it before that date, because something extraordinary is unfolding right now, hidden behind our star. The interstellar object 3I Atlas, only the third visitor from beyond our solar system ever detected, has just entered solar conjunction, completely obscured from every telescope on Earth. 5 days ago, on October 21st, Atlas moved directly behind the Sun, invisible to all instruments. In just 3 days, on October 29th, it will reach perihelion, the closest point to the Sun in its million-year journey through interstellar space. At that moment, its surface will be bombarded by 33 gigawatts of solar radiation, roughly a third of the total energy output of all U.S. nuclear reactors combined, concentrated on a single alien object. This is the most energetic phase of its entire existence. And yet, we can't see it. If something extraordinary is happening, massive sublimation, complex chemical reactions, or something beyond our understanding, it would be happening now, in total observational blackout. So why now? Why does this object, already marked by countless anomalies, pass through its moment of maximum solar energy exactly when it's hidden from us? Coincidence? Or something more fundamental? Harvard astrophysicist Avi Loeb warned, "If you plan to take a vacation, take it before October 29th, because who knows what might happen." Those words, once speculative, now echo with urgency, because Atlas isn't just another interstellar rock. It's rewriting the rulebook. The 5 great anomalies. 1. The impossible orbit. Atlas's path lies just 5 degrees from the ecliptic plane, the flat disk where all planets orbit. The chance of that happening by accident is 0.2%. But that's not just luck, it's the perfect trajectory. If someone wanted to pass near multiple planets, Mars, Venus, Earth, Jupiter, with minimal energy, this would be the ideal course. 2. The strange chemistry. Spectroscopic data from the Keck 2 telescope revealed massive nickel emissions, unlike any natural comet ever seen. On Earth, this specific nickel signature only appears in industrial alloy production, not in nature. Even more puzzling, cyanide extends farther than nickel, despite its higher volatility. These aren't random outgassing patterns. They suggest organized structure. 3. The missing water. Atlas is only 4% water by mass. Comets are usually mostly water. This makes it fundamentally different from every comet ever studied, including Borisov, the previous interstellar visitor, and the light it reflects is extremely negatively polarized, something never seen before, implying an unknown surface material or design. 4. Enormous scale. Atlas weighs an estimated 33 billion tons, making it 1,000 times more massive than Borisov and 1,000,000 times larger than Oumuamua. That's enough to carry thousands of probes, or even larger structures, and still maneuver under solar power at perihelion. 5. The anti-tail. During July and August, Atlas developed an anti-tail, material ejected toward the Sun. That's not a trick of perspective. It means the object was actively expelling matter against solar radiation pressure, a sign of internal energy or propulsion. These anomalies have pushed planetary defense protocols to unprecedented levels. For the first time ever, the International Asteroid Warning Network, IAWN, activated emergency monitoring for an object that poses no impact threat. The campaign began October 27th and runs until January 2026, treating Atlas as a potential planetary threat despite its safe distance. Meanwhile, NASA's Mars Reconnaissance Orbiter captured the most detailed images yet, but hasn't released them. Harvard's Avi Loeb has repeatedly requested access, and NASA's silence is deafening. ESA, by contrast, released partial data showing a comet-like shape, but spectra that only deepened the mystery. Possible explanation scenario. 1. An exotic natural comet formed in a radically different star system, under strange chemical conditions, explaining its nickel emissions and low water. But this doesn't explain its precise orbit or perfect timing. Scenario 2. Controlled fragmentation. Atlas could be breaking apart in an organized pattern, revealing internal structures that react differently to solar heat. Scenario 3. Orbital maneuver. If Atlas changes speed even slightly during perihelion, a few meters per second, it could remain permanently in our solar system. Perihelion offers the Oberth effect, where even small energy bursts have massive orbital consequences. Scenario 4. Ejection of components. Atlas could release smaller bodies during perihelion, fragments that might later interact with Jupiter when it passes nearby in March 2025. The scientific community is split. Jason Wright of Penn State accuses Loeb of exaggeration and bypassing peer review. Loeb responds that the system moves too slowly for transient events. Atlas won't wait. The debate has become philosophical. Do we dismiss anomalies because they don't fit the model, or question the model itself? Current consensus: 75% chance it's natural, 25% it's something else. The coming observations. There are 3 key windows that could solve the Atlas mystery. November 4th, ESA's JUICE probe performs the first post-perihelion scan. December 19th, Atlas makes its closest approach to Earth. JWST and ground observatories will capture unprecedented detail. March 16th, 2025, Atlas passes near Jupiter, where NASA's Juno may record fragments or anomalies. If everything behaves as celestial mechanics predict, Atlas will confirm the diversity of interstellar comets. But if not, we face a new class of cosmic phenomenon. In 3 days, as Atlas reaches perihelion, it may be undergoing processes that defy everything we know, and for now, we are blind. In 3 weeks, the blackout ends. Telescopes will reacquire the object, and we'll finally know: was Atlas just another frozen relic from a distant star, or something else entirely? Whatever the answer, one thing is certain: the universe just got a lot more interesting.